Okay, well, thank you for coming to our talk. My name is François Proulx, and I'm joined today by my colleague Benoît Côte-Jodoin. We're both supply chain security researchers working at a Montreal-based startup called BoostSecurity. BoostSecurity is making an application security posture management product that helps software development teams build secure code, secure software, and also build it more securely. So we're focusing on supply chain security aspects for that. So the backstory behind the talk is that, when it comes to supply chain, as we see throughout the different talks so far today, we hear a lot about the management of dependencies, like known vulnerabilities, CVEs that have an ID, and we're really talking about managing, making an inventory with SBOMs and detecting the vulnerabilities that are related to those components with SCA tools. So, the tooling, the data is fairly mature by now. It's, getting more common to see it being used at scale. We hear, people from Comcast use it and all that. That's great. But also, on the other hand, when we talk about supply chain, we hear in the past years about malicious packages being published to different package ecosystems like NPM and PyPy. But there, really, the issue is often more about typo squatting, kind of, convincing someone to install the wrong package, dependency confusion, or that the actual legit, project was co-opted through some kind of phishing, credential stealing, or more recently with XZ, the actual, maintainers got social engineered into becoming legit contributors, and that's very hard, as we know. So the part that we're interested in and that we've been doing more research in the past year is really about the build pipeline of those packages, which we think is not as much on most people's radar, and there's really a lot still to be discovered in that area. So there is the OWASP CI/CD Top 10, which you may have heard about, which is pretty good. It's a good inventory of the types of threats you want to care about when it comes to build pipelines. There's also SALSA, which I'll mention in a moment, but it really doesn't provide much actionable remediation guidance. And also the other thing, we talk about SBOM, but when it comes to the build pipelines, you also have dependencies, which cannot be tracked by most, actually, to our knowledge. Correct me if I'm wrong, but we're not aware of existing SBOM tools that really focus on the dependencies in the build part of the SALSA. And also there's kind of suspiciously few CVEs for the build time components, such as GitHub Action components or Circle CI orbs. In the case of GitHub Actions, there's literally 20 CVEs that are on the OSV database, for instance. And we think, based on our knowledge, the original intuition for all that was that it cannot be, and there must be more to be discovered. So if we peel, back and look at what's inside of the build pipeline, we've heard in previous years, of course, like the SolarWinds attack was focusing on the CI of commercial software, but the same idea applies to open source packages. And when you look, deeply at build pipelines, often it's really messy. It's really complex, very hard to analyze the behavior, and again, like without good, reliable tools to produce an SBOM, it's very hard to even know what's inside, and especially transitively, basically impossible at the moment. There's also, curl pipe bash things, downloading random scripts, executing them blindly without verification. Is still very common in the build pipeline space. Also, most tools, compilers, linters, test tools, even SAS scanners, were often not designed with a scenario where you will have arbitrary contributions through pull requests, for instance, from like rogue actors that might influence the build pipeline. And, so that's been an area of our focus too. We think that build pipelines should have the same level of scrutiny as production systems, because they're really as important as production systems, or at least, because it influences the final build artifact. So where does this fit in Salsa? We're focusing today in our talk on the build part of Salsa, especially the build time dependencies, and not so much the dependencies that go in the final package. Really those that are not in the final package, but really have a major impact on the behavior of the build pipeline. So it already calls out two main threats: use of compromised dependency and compromise the build process, which is what we're going to talk today.
So in order to try to find these vulnerabilities, we were finding them manually at first, but then we started building this deciduous attack tree that we're not going to dive all the way into it, but it just kind of shows the sort of mental model that is required to securely review a workflow, but in this case, it's only specific to GitHub Actions. Then in sort of the bottleneck of this attack tree, we really wanted to focus on things that were like one-click sort of exploits. So we found that we sort of always needed a sort of a code execution that can come into the form of a pull request that's been previously documented, or sort of workflow injections. But then once you get into the pipeline, you have to ask yourself, what is the impact of this? And so compromising a GitHub Actions can have downstream effects recursively. They may depend on other GitHub Actions. So it's a fun sort of graph of packages that's involved in the pipeline. If we look at what's the most common sort of pattern for a pull request, this is the sort of steps we were looking for. So a GitHub repository, obviously, that is public, that uses GitHub Actions. Then in this repository, we find a workflow typically that triggers on pull request target. It's the most common culprit of these sort of issues, but there are also other events. The workflow makes use of sensitive secrets, or inherits the default GitHub Actions permissions, which by default grants read-write access on a repository. And then there needs to be some sort of code execution. So there's two main ways we see this. The main one, script injections, usually through bash. There's a lot of bash and CI pipelines. Or another angle we like to look at was the build tools that have inherent properties that allow code execution that aren't really intended to be exploited, but came in useful. And then at the end of the process, when you are in the pipeline, then you can sort of start thinking at pivoting and sort of evaluating the impact of this compromise. So this is an example of a GitHub Action workflow that has several issues that we are interested in. We're not going to
test. Okay. Thank you.
Okay, so pull requests. So yeah, in the context of a pull request, what we're looking for is three main issues in this workflow. So the first one is the event on which the workflow triggers, pull request target, the main culprit, as we talked. Then we call this a privileged checkout, or really it's a checkout that specifically pulls in the head of the pull request. So the changes that are being submitted through a pull request are immediately downloaded. And then there's a step that will sort of allow code execution. So in this case, there's a make command. And so if a pull request comes in, modifies the make file, that make file is going to execute code directly in the pipeline. And so now, to find these issues at scale, we faced the problem. There were not readily available tools that would efficiently analyze a lot of dependencies. So we created this project called Package Supply that really focuses on trying to analyze the build pipeline, especially of those packages that are not typically in your SBOM, sort of Terraform modules or Helm Charts or Circle CI orbs. These sort of things have very impactful powers over a pipeline, but may not be well tracked. And so to analyze this, we'll clone the source repository. We'll parse all the workflows that we find and any other interesting information so that it can be indexed. Then we'll run some static analysis tooling. And at the end of this process, we end up with sort of a build inventory, so kind of an endless bomb that we use to analyze all of the dependencies of that packages. So organically, we end up finding a lot of these one-off GitHub actions that are in the build pipelines of a few organizations. And to kickstart this process, we scraped quite a few packages from GitHub, from the Terraform registry, and the largest amount of GitHub actions we could find. And so once we have all this data, there's two main ways that we query it. The main one is BigQuery, and this is really useful to test heuristics quickly instead of running a tool 1,000 times every time that you want to change your detection rule. It's really fast. And then there's a Neo4j that's a bit more experimental, but we're hoping with this to build sort of a package graph and then find, hopefully, transitive attack path through multiple packages. Okay. So this is an overview of some of the data that we have gathered and some of the stats about heuristics that we're using to find these spawn requests. Maybe a word on the default permissions one. So essentially what this means in the case of GitHub repositories is that there are 87% of the repositories that we found on GitHub did not specify permissions in them. And on its own, it's not really an issue. It depends on the settings of the organizations or the repo. But then when you start combining it with the other heuristics, that there may be a dangerous workflow, there may be a potential PR checkout, you start getting really, really high accurate findings, which François will talk about.
Okay, so using that package supply project, we were able to, analyze at scale, and we keep adding more and more every day. Like, it automatically scrapes and detects more projects. So we've gone ahead and wrote a bunch of rules, which allowed us to narrow down many 0 days, which we've disclosed. Some of them are still pending disclosure. So those are just generic examples, like they're actually real examples of things we've disclosed, but we've kind of anonymized it. Some of them, we had a big focus on Terraform modules because we thought that was a very interesting kind of package ecosystem that was simply ignored by most people. So it's the Terraform registry is a package ecosystem, and it automatically pushes to that registry just by merely tagging on GitHub. So if you have some kind of remote code execution that is able to tag, you can basically publish. And you even have like transitive dependencies in Terraform modules, so you start to kind of layer two things together, like vulnerabilities in the build pipeline of Terraform modules transitively starts to be very interesting. We found that on very high-profile projects, not to name it, like AWS and others, like and like very popular Terraform modules were vulnerable to that. We started to find some common patterns when it comes to the types of tools that were vulnerable to so-called pwn requests. So much so that we created another project called Living Off the Pipeline, which makes an exhaustive inventory. You're more than welcome to contribute to it. Of those tools like compilers, linters, test tools that in many cases have much less obvious behaviors. Of course, makefile. If there's a makefile, you run make in the current working directory, it's going to run arbitrary code, of course. But there are others that have config files that most people don't even know exist, and you think it's safe to run the tool, but it's not. Gumplate is one such example. So today we're announcing an open source project, open source security scanner called Poutine. As I mentioned, we're a Montreal-based startup, so it's only fitting. And it is really focused on those build pipeline things. So we've built package supply, and out of that, we kind of narrowed down a number of key insights that we found were very good indicators of vulnerability. We baked that into this tool, which you can run very easily, very efficiently on a whole like GitHub organization. You just point to it. Even on organizations which have upwards of 1,000 repos, even large ones, it can come back with results within just a few minutes. So it's very easy to run. You just need a token. You can look at the public repos, and you can just as easily include it inside of your build pipeline to check your own repos. So go ahead and give it a try. So what does it look like? It's a simple tool you can install with Homebrew or on Mac or a Docker container. And those are just some examples of the vulnerabilities it can find. And you can output with Serif. It integrates with GitHub Advanced Security and all that. The other thing is, as you might have noticed, there's an organization called Messi Poutine, which is in fact a GitHub organization where you can go and learn about real types of vulnerabilities which we've seen in the wild. So this is kind of a capture the flag competition with like a sort of a training that you can learn what it looks like, and you can just exploit those things and capture flags and submit them and see if you disapprove that you exploited it. So we've gone ahead and built that to even just test our own tool, but we thought it was a fun thing to share for people to learn about how to actually exploit those things. So the key takeaway is that build pipelines are very complex. There's still a lot of things to be discovered. We're just starting to scratch the surface of the build side of SALSA. Currently, the tools that we have a fairly shallow level of analysis and insights, but we have very interesting ideas. We want to work, especially as we mentioned, the transitive dependencies with graph database is one such area that we're working on. And there are a number of real-world attack scenarios that are very easy to exploit. You go ahead and try it with this Messi Poutine project. You'll convince yourself that it's actually fairly easy if the right conditions are in place. And yeah, we need more tools, more data to even start to understand the scale of the problem. So if you want to learn more, like sharing some more links again, we have a number of blog posts that we made in the past year about the different research that we did, different disclosures, attack trees. The first two contain detailed attack trees for SCM like GitHub and GitHub Actions. The attack tree that we showed on the slide is not shared, but if you're curious, come talk to us. We'll share it privately. And yeah, so that's it. Any questions? There's someone from GitHub in the audience, which I can talk to privately after. But yeah, yeah, we run it. The pack, as I said, this small CLI, we built it after we made this kind of backend infrastructure. We want to improve the backend infrastructure to collect the data at scale. And yeah, there is more opportunity maybe to collaborate to kind of keep that up to date. But otherwise, yeah, the tool, the small CLI is just focusing on one level of it doesn't do transitive dependency, but yeah. Yes. Yes, go ahead.
Have you thought about looking at the XC thing?
Mm-hmm.
There's a build pipeline issue as well.
Yes.
Have you been looking at all into the various Linux distribution pipelines?
Well, in fact, if it had GitHub Action workflows in there, we might have it in package supply. So if there are specific projects you're curious about, come talk to us. We'll crack open BigQuery and we can look at what's in there. We have upwards of anywhere between 100,000 and 500,000 repos ingested. And if you're curious, we can write a query together and see what's there. That's it. Thank you.